Numbers in chemistry can range from very large. So you could have the number of particles in a mole is 6.02 times 10 to the 23. That's with 23 zeros behind it. It's very large. Or you can have very small numbers, say the size of an atom, which is something times 10 to the minus 10 meters. So very large numbers or very small numbers need to be represented in a way that's simplified. And also if we want to represent correct significant figures, so if I had the number 200, but I wanted to represent it with three significant figures, I could do that using scientific notation. So there are two parts to a number in scientific notation. There is the A part, which is going to be called the coefficient. And a coefficient is a number that is between 1 and, say, 9.999999. So it's not going to be 10. The other part of a number in scientific notation is the B part, and that is called the exponent. This is going to be any positive or negative whole number. So we won't have numbers with decimal places in them. It'll just be 1, 2, 3, or -1, -2, -3, etc. A couple of things to note in scientific notation that a number that is greater than 1, so this example here, this is the speed of light in miles per second. Positive exponent, notice that's a plus right there. So it has a positive exponent. That can be helpful when you're looking at your numbers to know whether they're big numbers or small numbers. So big numbers have positive exponents. And a number less than 1, or a small number, see this number is less than 1, has a negative exponent. So again, if you're looking at just really quickly, is this number big or small? Look at the exponent. If it's positive, it's a big number. If it's negative, it's a small number. Here's some examples. I have two numbers here. The large number on the left this is the speed of light in meters per second. And then I have just a very small volume here. I'm going to focus on the first number. Move the decimal point to give a number between 1 and 10. This is step A. So I'm going to do that for the large number. And it says move the decimal point, but there isn't a decimal point. So what does that mean? Well, it means you have to place a decimal point at the end of the number and move it so that it's between, the number is between 1 and 10. So this gives me the number 2.998. Now 2.998 is very different than this other number, which is in the billions or maybe even trillions. So in order to keep the magnitude of the number, the next step is to multiply, this is B, by the number by 10 to the x, where x is the number of places the decimal is moved. So now let me go and count how many places it's going to be moved. 1, 2, 3, 4, 5, 6, 7, 8. So now I'm going to multiply this by 10 to the 8. So the overall number is 2.998 times 10 to the 8. And let's remember the units, meters per second. Notice that I moved the decimal place to the left, and that made x positive. That's because I was working with a large number. So now let's look at the number on the right. Looking at A, it says move the decimal place. It's obvious we have a decimal place here. I have to move it. And I'm going to get a number 2.45. Now 2.45 is definitely not the same as 0.00245. So the next step is to do B, and I'm looking for 10 to the x. I'm going to see how many places I move it. 1, 2, 3. So this is times 10. And I'm writing 3 here, but look, I have to make it negative because this is a small number and I'm moving to the right. When I move the decimal place to the right, x has to be negative. So I'm writing it as negative. And so I'm going to write this as 2.45 times 10 to the minus 3 liters. And that will be my answer for the small one. And 2.998 times 10 to the 8 is my answer for the large one. This slide covers information about how to use a calculator. And there is also information on the math and chemistry Canvas shell about this. I'm recommending using the TI-30X2S. We have those in lab, and we also, the library has them, and the Accessibility Support Center has them. If you're going to follow the directions for that, you enter the coefficient, and then you press second, and then E. If I wanted to enter 4 times 10 to the 6, I do 4, and then I do second with EE, and then 6. And just practice this with your calculator or your phone or whatever you're using. And make sure you know how to use the calculators that are in the lab, which is again the TI-30X2S. This is what I recommend.